material. Okay, yeah, everything's going great. Okay, it's my pleasure to be speaking today with Adam Hill, and Adam Hill is the head of screening at Novartis, and it's a pleasure to have him be part of this course and to bring his expertise to the students within this edX course. So I want to start the interview by asking Adam, could you please tell us what your position is at Novartis?
Sure. So I work for a platform within Novartis called the Center for Proteomic Chemistry. We're a support function to the disease areas, enabling them to do lead discovery. I work as one of the heads of two operations within CPC, one based in Cambridge here, which is me, and one based in Basel. And between the two of us, we manage the high-throughput screening for the early drug discovery for Novartis.
Could you tell us, Adam, how you came to be to Novartis, what your educational background or professional background?
Sure. I did my undergraduate and graduate work at the University of Oxford in England. I came over to the United States about 25 years ago as a postdoc researching into anesthesia at Harvard. From there, I moved down to the University of Connecticut, and in the mid-1990s, I set up a didactic 3-credit course in high-throughput screening at the University of Connecticut, as well as a small lab to do practical hands-on work. I realized at that point you needed money to do high-throughput screening, and so moved into industry. I joined Schering-Plough in 1997, and from there, I moved through their group to Millennium in Cambridge, Massachusetts. They moved on to Novartis just over 10 years ago. So I've been with Novartis now 10 years, and risen to the role that I now hold, which is the head of screening.
Great, Adam. I'm sure your days aren't always typical, but as much as possible, could you describe what sort of activities you engage in on a day-to-day basis in your position?
Sorry, I lost the connection there.
Okay, we'll just go back and try that one again. Because your answer, you were breaking up a little bit, but I think you were fine for the video, but maybe I was losing it on my end as well.
Okay.
So Adam, I'm sure your days aren't all the same, but as much as possible, could you describe what defines some of the typical day-to-day activities you have in your job?
Sure. So my group is about 65 people. It covers sample management, it covers engineering, it covers the biology associated with lead discovery. So on a typical day, probably about half the time is spent on the biology and understanding the biology around the targets that we're running at a particular time. Some of my day will be involved with discussing where we're going in the future, building out the next generation of screens and so forth. And certainly a lot of it at the minute for me is around people management, making sure that we have areas for people to grow. On the biology side, on the practical screening side of things, things are quite automated. The robots, letting them run, etc. But most of my time is really around making sure we get the right biology and that we have the right equipment to be able to run that biology efficiently and effectively.
You mentioned you have a pretty good blend of a little bit of chemistry and biology. Can you talk about, if they can fit in categories, can you talk about what is the blend between the number of biologists and chemists you might have working under your supervision?
Sure. Most of the people working in my group are biologists, I would say. We have some engineers. The people in sample management, again, it's mostly around the process there, so not necessarily a chemistry background, but some people do. And I mean, I myself grew up a chemist and have transitioned more into that biology role over the years as well.
Okay. Excellent. So can you, Novartis has a long history the name Novartis has not been around as long as maybe some other companies, but historically the company goes back a long ways. Can you talk about the size of the collection, chemical collection at Novartis, and some of the origins of that collection?
Sure. So, yeah, like you say, I think Novartis is about a 250-year-old company, if you go all the way back to the beginning. Novartis was formed 1996, I believe, merger of Ciba-Geigy and Sandoz. So the compound collections from those two organizations were brought together under one roof. From that, we have been quite active in managing the library. So while the numbers that we actually screen come down to around about 1.2 million compounds that we would typically test. We enrich that archive by about 100,000 a year. At the same time, we're decrementing by almost the same amount things where we've run out of material or it's degraded beyond our QC criteria, things like this. We actually recycle the whole screening library every 6 years from powder. So there's a constant updating of the library that we would test. We also have quite a strong natural products group. So I think we're one of the few pharmas that have natural products in our collection and are actively growing our natural product supply as well. And so this really does nicely augment the synthetic chemistry that we're typically adding to the collection.
So when compounds are being put forward and are being screened, such as in the early stages of a drug program, what fraction of the entire collection would typically be screened against new compounds that are being submitted?
Sure. So the way we would typically operate is that when we're coming up to a target, we either have a very clear idea of what we're looking for in terms of the readout in the biology, or it may be a little bit more nebulous. If we absolutely know what we're looking for and how we would progress that chemical matter, we may actually take the full deck, the 1.2 million compounds, right up against it, right off the bat. If we're not quite so clear as to what the right readout would be, we would actually take a subset of that. And that could be anything between 10,000 and maybe 250,000 compounds that we would test in maybe 1, 2, or 3 different assays. Taking the hits from that and progressing those down to what I would call a gold standard or a truth-telling assay. Understanding what the hits were that were giving us the real hits in that downstream assay, and then picking the appropriate assay to come back to for the primary screen, where again, depending on the amount of chemical matter we need or the questions that we're answering with that chemical matter, we may go up to a full deck again, or it may be that we would do an iterative cycle and maybe go a little bit deeper into some of the hits that we had using SAR by archive, for example, or other approaches.
Screening is definitely not my strong suit. I am a synthetic chemist and still am really a synthetic chemist. Can you talk about how approaches to screening have changed over the past decades?
Sure. So if you consider maybe 10, 15 years ago, the human genome came out, people would go through and pick out their targets, GPCRs, whatever it may be, and then throw their whole compound collection up against that particular target in really the first assay they would come across. They would then take that chemical matter, progress it, and see if it actually produced anything tractable against a disease that they thought that particular target was associated with. I think now we take a much more pragmatic approach. We look at the disease first. We look at what it looks like in humans. We then look to see if there are animal models that could equate to that, and then bring that back then to what we would look at in a primary screen. So trying to make sure that the biology is absolutely relevant is the key. Similarly, as I just described with the chemical matter and how we put it up against it, if we are unsure of what the best readout is, we will take a small fraction of the library first. Test that, look to see if we are actually getting what we would like from that assay in the downstream truth-telling assays. And then we would back up again and do the iterative screening or the full deck or however many compounds we needed to throw against it. So it's very much more, I would say, biology, disease-driven now, maybe than, say, 10, 20 years ago when I started, when it really seemed to be a sort of rush to find whatever we could first pass from a genomic target.
So, Adam, when you discuss these assays, are these typically standardized protocols that you can find in the literature, or in general, does Novartis have to design strictly kind of proprietary protocols that almost become a trade secret in their own right?
Yeah. I would say most of the assays that we run are things that you could find off the shelf. Certainly we collaborate a lot with vendors, ensuring that we have the appropriate reagents for particular readouts. I would say cell-based assays are maybe a little bit more proprietary than biochemical assays, where you're typically looking for one or two analytes in a biochemical assay. The standard fluorescent resonance energy transfer type assays, the colorimetric type luminescence readouts, those sorts of things. Those are all pretty standard off the shelf. Anybody could get at them. And minimizing false negatives, of course, as well. But we tend to go with, I would say, off the shelf. We have a few, what I would say, maybe cutting edge readouts that we've developed ourselves. But again, nothing that you couldn't read in the literature. And certainly from a Novartis perspective, we like to publish when we can.
Great. So could you give me a sense of time scale? You mentioned perhaps testing the entire collection against a certain target. How long what would the turnaround time be for that test as for a biochemical test, some sort of high throughput screen versus something like a cell-based assay? Or would you even screen the entire collection in a cell-based assay?
Sure. So again, it's a little confusing to speak of precise time frames because there's an awful lot of prep work, right? So how long does it take to say from launch to the moon? It's really not that long compared to the 10 years of building the rocket to get there. Same thing's true with screening. So typically, I would say that from concept to tractable chemical material, we're looking about a year. For a biochemical screen, it really doesn't matter whether it's small or large. For a simple readout, we can get through the 1.2 million compounds in a couple of weeks, just physically on that screening stage. But getting to that assay, getting the proteins that we would need, the enzymes made, scale up, etc. That's typically 3 to 6 months to get to that point. Once you have that primary screen, then you go back, you cherry pick, you retest, you maybe put in a couple of other assays as well to validate that you're getting the right materials out, and so all that time adds up. So for a simple assay, it's maybe closer to the 6-month time frame overall. If you're looking at a more complex cell-based assay, it's usually a little bit longer because, again, now you've got the cell supply coupled to the assay. The number of plates that you can run a day typically reduces a little bit, but we've run simple cell-based assays at the same speed of biochemical, or a more complex readout. I would say, you maybe only get to a point where you're looking at maybe 50,000 compounds a week. So again, that time scale shifts. The question of how many compounds you run against a particular assay, I think very much depends on the question you're asking. So if you're looking for a tool molecule, if you're looking for something just to prove the biology or show you can do it, that's one thing. If you know exactly what you're looking for, then maybe you want to run the full deck. And get the maximum amount of information that you can right off the bat.
Great. As always, things are never as simple as they seem at first glance. Right. Could you talk about plate formats? I think I'm most familiar with the 96 well plate, but that's not as high throughput as maybe you would have. There are also 384 well plates, and 1536. Can you talk about the format that you would typically work with, maybe in a high throughput screen or a cell-based assay? Is there a difference?
Sure. So I think 384 is our entry, if you like, of choice in terms of format. Most people can manually pipette into those, particularly with electronic handheld pipettes. What we've been encouraging is to do everything in 1536. So actually start off in the format that you would like to screen in to start with. I think we have enough knowledge now of the transition from 96 to 384 to 1536 to understand where the problems may arise, and enough understanding that we could actually start in 1536 right off the bat. We have had cases where 384 doesn't translate to 1536, but it's now becoming less than 5% of the assays that we actually develop. So using automation, using flexible dispensing systems and so on, we can actually start right off the bat in 1536. This reduces the reagent requirements we need, and also means that we don't have to adapt the assay once we've generated it in 384.
So what are the specific challenges that that cause hangups in that transition?
So it's really around plate dimensions and volumes. So it's just maybe the biggest one is surface area to volume. So quite often for assays we would have detergents in there to try and keep things off the walls. And we would just try and make sure that the amount of signal that we're getting is high enough in 1536 relative to 384. That tends not to be a problem anymore with the brighter dyes and the fret systems that we have. But for some reason, some biologies only work in 384 versus 1536. Plate type makes a difference. We tend to use COC, which is a relatively chemically inert where we can, but certainly polystyrene or polypropylene or COC will give you different results. A lot of that depends very much on the porosity of the plate and so on. So we found pretty much with detergents or carrier proteins we can overcome most of the issues in translation, but you never know until you try it exactly what's going to trip you up. But something will.
Adam, that was great. Thank you very much for being willing to be interviewed for the course. It gives great insight into some of the challenges and insight using the language that we've seen in the course, but of course taking it quite a bit further and demonstrating some of the challenges that are unique to your field and your contributions to drug discovery. So I want to thank you again and hope you have a wonderful weekend.
Great. Thank you.
Take care.
Okay. Did you get what you needed? Is there anything we need to go back
That was
over?
phenomenal. No, that was great.
Okay.
There was, I got a little messed up on target and compound in that one question. You were very gracious. You didn't make an ugly face. You just let it go. I appreciate that very much.
Oh, that's good. Is there anything else we can do for you here? I mean, we have videos of the automation and stuff like this. We have...
Yeah, that way. I mean, absolutely. If you all have short video clips, and if that's something that we could include in the course, that's because to see a deck in action with the robotics. I mean, that's impressive.
Sure.
So that would be fantastic. So your interview is technically in week 5 of the course, and we are just getting ready to start week 4.
Okay.
So it won't be until next Monday, which is at the 10th. I'm not sure what, but around November the 10th or so, that this week of the course will launch that will have your video. So
Okay.
if there's some short clip that you could send along, that would be fantastic.
Yeah, I mean, they usually tend to be quite big, but let me see what I can do in terms of working with Ross and getting some videos down to you, because I think, like you say, I think seeing it in action is really the key.
Oh, yes.
And maybe just getting a little bit more of an understanding of the scale of what we do, because I think it is different to a lot of areas, and it's some of the machinery we have is quite impressive. So.
Oh, I'm sure. And just hearing you talk about, for some targets you'll throw the entire collection. I mean, that's very cool. I mean, it really is. It's you screen that number of compounds in a matter of weeks. Given preparation time,
yeah.
In a matter of weeks you can have the entire collection screened. I mean, maybe for your line of work that's less impressive, but it's fascinating to me that how you can muscle through and handle all that data. And it's a lot of information to track.
Yeah. Yeah, no, I think so we've now got a mass spec running at less than a sample a second, for example, which I think is pretty superb. And we run some of the mRNA detection that we run. We've got that running now, so we can run 88,000 wells a day, and that's 8 genes per well. So again, this is the sort of scale that we operate on. It's crazy.
One question I did not ask you, and I didn't read it properly, but I did have that question about the format, and this would be assuming I've heard 386 wells per plate. You can screen 16 compounds in duplicate at 12 half-log concentration units. Is that a typical dynamic range for the concentration of a screen? What sort of range?
No, so typically, primary screening we run as a single dose.
Okay.
And then the follow-up would be concentration response. We typically run 8 concentrations. Basically, what is that? 44 samples per plate. So 8-point dose response. So most of the screening hits that you get are at the very high end of the concentration. So that would be, the 1 to 10 micromolar type IC50. Very rare that you get below a micromolar. So having all those extra data points down below 1 micromolar really doesn't help you. At that point you take it, you're happy, you move on.
Sure.
But then when you get down into the med-chem range and you start really optimizing, then yes, you need to know much more where you are in that dose response range. So sometimes we'll take that out to 12, but most of the time we'll stick, or 11 actually, so you can run 2 across the plate. But most of the time it's either two-fold serial dilution, third log or half log would be the numbers that we use. Okay,
fantastic. Well, Adam, thank you so much. Thank you for making yourself available on pretty short notice and working this in on a Friday. We are doing everything. It seems like we're always behind, and so it's nice to feel like we're getting actually ahead of the curve. So I very much appreciate your flexibility.
Oh, not a problem. That's great, and I support everything you do. It's great to see this sort of thing going on. So.
Great. Well, thank you very much, Adam. It's a pleasure talking with you. I'm sorry I'm so awkward. It's just this interface is not the most interpersonal way to communicate. So
no. That I'm getting back to me is very good. So,
right.
Yeah, we've used Live Meeting as well. Have you used that?
We have not. Maybe GoToMeeting we've used. I haven't tried Live Meeting.
Okay.
This was a format that we thought we could easily capture and get into a YouTube format, which is required for the course. So the course requires a YouTube, everything to be on a YouTube channel. But I am talking way beyond my understanding of instructional technology. I just do as I'm told.
Wow, that's great. Okay, thanks. Have a good week.
Absolutely. Take care. You too. Bye-bye.
Bye-bye.